Imagine a land, vast and breathtaking, where the very air can freeze your breath in an instant. A place where winter isn't just a season, but an absolute brutal force of nature. We're talking about regions where mercury plunges to a terrifying -30 degrees Celsius or -22 degrees Fahrenheit. For most, this means retreating indoors, bundling up in layers of high-tech gear, or simply enduring a bitter, miserable existence. But for millennia, before the arrival of modern technology, entire civilizations thrived here. They didn't just survive, they built homes, raised families, and developed a way of life that defied every expectation of what was possible in such an unforgiving environment. These were the true masters of cold weather survival. They crafted a dwelling so ingenious, so perfectly adapted, it stands as a testament to human innovation and resilience. This isn't just a story about ancient structures, it's a deep dive into the engineering brilliance, the cultural wisdom, and the sheer grit of people who unlocked the secrets to living comfortably in Earth's harshest winters. Get ready to discover the lost science behind what many mistakenly see as a primitive tent, a true marvel of sustainable design. At the heart of this incredible survival story is a structure often misunderstood, the conical lodge. But this was no mere temporary shelter. This was a sophisticated, purpose-built home, a mobile fortress against the elements, a warm sanctuary forged from natural materials. And here's a crucial, often overlooked detail. These magnificent homes were primarily designed, constructed, and owned by women. They were the master builders, the engineers, the architects of their families' comfort and survival. Their skill and ingenuity were paramount. The construction process itself was a marvel of efficiency and strength. It began with the selection of the primary supports. Picture 3 or 4 perfectly straight, robust timber poles, each extending a full 20 feet skyward. These were not just any poles. They were chosen for their flexibility and enduring strength, often from resilient cedar. These foundational timbers were lashed together at their apex using a material far stronger than any modern rope: sinew, the incredibly tough connective tissue harvested from large game animals like the great bison. This initial tripod formation wasn't just stable, it created a structural anchor, a base more resilient than virtually any contemporary tent frame designed for extreme conditions. It was the very embodiment of stability in an unstable world. Once the initial tripod was secure, another 10 to 12 additional support poles were meticulously leaned against this central frame, radiating outwards. This created a perfectly balanced conical skeleton, ready to withstand ferocious winds and heavy snow loads. The structural integrity was legendary, a testament to centuries of refined design. Now for the covering, the vital outer shell that transformed a skeletal frame into a true home. This required anywhere from 10 to 20 individual hides, depending on the desired size and purpose of the lodge. And these weren't just any animal skins. They were predominantly the massive, thick hides of the bison, an animal perfectly adapted to the cold itself. Each hide underwent a painstaking, multi-stage process of preparation that could take days. First, every scrap of flesh and fat was meticulously scraped clean, a labor-intensive task ensuring the hide's purity and flexibility. Next came the tanning, not with harsh chemicals, but through a natural, ingenious method: brain tanning. The brain of the very animal itself, rich in natural emulsifying oils, was worked into the hide, transforming it from stiff, raw leather into a pliable, incredibly soft material. This process was crucial, making the hides manageable to work with, allowing them to drape beautifully and resist cracking in extreme cold. But softness wasn't enough. The hides then received a vital waterproofing treatment. They were generously greased with rendered bison fat, creating a natural barrier that repelled water, ensuring that the lodge remained dry even during blizzards or melting snow. Finally, these perfectly prepared hides were skillfully sewn together. The seamstresses, again often the women, used needles crafted from bone and thread made from sinew, the same incredibly strong material used for lashing the poles. This created a durable, weatherproof skin that enveloped the entire structure, forming an impenetrable barrier against the elements. The entire process was a profound blend of art, science, and sheer physical labor, resulting in a covering that was both functional and beautiful. The basic conical lodge was a marvel, but to survive the brutal deep winter, it underwent an extraordinary transformation. This wasn't just an upgrade, it was a complete re-engineering, turning a robust summer dwelling into a super-insulated, energy-efficient winter fortress. This is where the true genius of these ancient builders shines through. When the first severe cold snap hit, families initiated a critical modification: the installation of an inner lining. This wasn't merely decorative, it was a secondary wall, typically made of lighter hides or sometimes, in later eras, canvas, suspended from a rope that circled the interior poles at about a height of 7 feet. Crucially, the bottom edge of this inner liner was weighed down with stones, creating a tight seal against the ground. This sealed chamber within a chamber was the first key to thermal regulation. Between the main outer covering and this new inner wall, a critical space was created. This space, often several inches wide, trapped a layer of air. This wasn't just any air, it was dead air. Just like the down feathers in a premium winter jacket or the fiberglass insulation in your home's walls, this layer of still air acted as a phenomenal insulator. It drastically slowed the transfer of heat from the inside to the outside and vice versa. This simple yet profound engineering marvel alone could raise the interior temperature by a staggering 20 degrees Fahrenheit. Think about that, a 20-degree improvement purely from a clever design modification. Outside, further insulation was added, but with incredible precision. Families carefully packed snow around the base of the lodge. However, there was a crucial rule. The snow was never allowed to directly touch the hide. A small, intentional gap was maintained. Why? Because direct contact between snow and hide could lead to moisture transfer and, eventually, rot, compromising the integrity of the dwelling. Instead, the snow created an external insulating bank, a thermal barrier that further protected the lower portion of the lodge from penetrating cold, without risking damage to the materials. Some families took insulation a step further, stuffing dried grasses or fibrous plant materials into the gap between the liner and the outer cover, enhancing the dead airspace with additional natural insulation. Others innovated with an ozone, a partial ceiling or smoke flap, positioned above the fire pit but below the smoke hole. This clever addition served a dual purpose. It trapped warm air that naturally rose, preventing it from immediately escaping. And it also prevented downdrafts of cold air from plunging directly into the living space. Every element was a testament to applied physics and meticulous observation. At the absolute center of this marvel of engineering was the fire pit, a carefully constructed depression surrounded by a ring of stones. This wasn't just where heat was generated, it was the heart of a sophisticated ventilation system. Fresh, cold air was drawn in at ground level, subtly entering beneath the weighted edge of the inner liner. This cold air, denser than warm air, would hug the ground, flow towards the fire, and as it hit the flames, it would rapidly heat up. This heated air, now lighter, would naturally rise, creating a powerful convection current. The inner liner, extending upwards, effectively created a natural chimney, directing the smoke and hot air efficiently towards the smoke hole at the very top of the lodge. This chimney effect was so effective that smoke exited cleanly, even on windless days, preventing the interior from becoming acrid or smoke-filled. Two adjustable flaps at the pinnacle of the conical lodge, controlled by external poles, acted as ingenious dampers. They could be meticulously adjusted to direct smoke away from the dwelling, regardless of wind direction, ensuring optimal ventilation and preventing smoke from pooling inside. It was an intuitive, low-tech solution to complex airflow dynamics. But the ingenuity didn't stop there. On particularly calm nights, when the natural chimney effect might be less pronounced, or simply to ensure a robust, clean-burning fire, some families employed an additional innovation: a small, carefully dug tunnel from the outside that led directly to the base of the fire pit. This provided a constant, direct supply of oxygen to the flames, keeping them burning hot and clean, completely independent of the air within the living space. This meant the interior remained wonderfully draft-free, while the fire received all the oxygen it needed to generate maximum warmth. It was a brilliant example of understanding and manipulating airflow for ultimate comfort and safety. The radiant heat from the central fire was effective, but what about maintaining warmth through the long, dark hours of sleep? Here, too, ancient builders had a solution that predated modern heating pads by millennia. Before retiring for the night, stones were carefully selected and placed directly into the coals of the fire until they glowed a dull red, thoroughly saturated with heat. These heat batteries were then carefully wrapped in insulating hides and strategically buried beneath the sleeping areas. Slowly, steadily, these heated stones would release their stored warmth, radiating a gentle, consistent heat that kept occupants comfortable for hours, long after the fire had dwindled to embers. It was passive, efficient, and incredibly effective. And what about when the community had to move camp, a frequent occurrence in their nomadic lifestyle? How did they carry the precious gift of fire with them across vast frozen landscapes? The solution was simple yet brilliant. Hot coals, carefully selected for their enduring heat, were sealed within hollowed-out bison horns. The openings were then expertly plugged with clay, creating an insulated, oxygen-deprived chamber. This ingenious method allowed the vital flame to be preserved, smoldering safely, sometimes for days, as the community traveled to its next location. Fire, the ultimate survival tool, was never truly lost. On the vast open plains, a critical challenge was the scarcity of wood. While hardwoods burned longest and hottest, they were not always readily available. This necessitated an incredible resourcefulness in sourcing fuel. One of the most surprising, yet highly effective, alternative fuels was dried bison dung, affectionately known as buffalo chips. Collected by women and children before the onset of winter, these dried organic patties burned with a surprisingly intense heat and produced minimal smoke, making them an ideal and abundant fuel source for the central fire. They were nature's briquettes, freely available and endlessly renewable. Another ingenious fuel source came in the form of tightly twisted bundles of dried grasses. These bundles, often compressed and tied with incredible strength, would burn slowly and steadily, much like manufactured logs. They offered a prolonged, consistent heat, making the most of every available plant fiber. This innovative use of readily available materials underscores the deep connection to their environment and their unparalleled ability to adapt and utilize every resource at hand. Beyond the home, personal warmth was paramount. The clothing systems developed by these incredible people were just as sophisticated as their dwellings. Central to their winter wardrobe were bison robes, but these were not mere blankets. They were highly engineered garments designed for ultimate thermal efficiency. These particular robes were sourced from bison killed between November and March, when their winter fur was at its absolute thickest and most insulating. The hides underwent a meticulous preparation process, scraped clean, then worked with bison brain and marrow until they achieved an unparalleled softness and pliability. Finally, they were smoked over a fire, not just to preserve them, but to impart crucial waterproofing qualities, ensuring they shed snow and moisture effectively. The key to their warmth lay in how they were worn, fur side inward, directly against the body. This created a dense, insulating layer of trapped air, utilizing the natural properties of the fur to maximize warmth retention. The decorated outer hide side was designed to shed snow and moisture, protecting the inner fur layer. Often, multiple layers were worn for maximum protection. An inner robe, perhaps made from a softer calf hide, would be worn closest to the body, followed by a thick outer bison robe. This layering strategy created multiple dead air spaces between the garments, multiplying the insulating effect. This system was so incredibly efficient at trapping and retaining body heat that individuals could work outdoors for extended periods in sub-zero temperatures, sometimes for hours, without succumbing to the cold. Their clothing wasn't just protection, it was an extension of their brilliant thermal engineering. In a landscape where fresh food could be scarce during the long winter months, sustained energy was non-negotiable. The people of the plains developed the ultimate survival food, pemmican. This wasn't just a meal, it was a concentrated energy source, a nutritional powerhouse designed for endurance and portability. Pemmican was made by first drying lean meat, often bison, until it was brittle. This dried meat was then meticulously pounded into a fine powder. To this, rendered animal fat, typically bison tallow, was added and thoroughly mixed. Finally, dried berries, rich in vitamins and antioxidants, were incorporated. The result was a dense, nutrient-packed food, where just 1 pound contained an astonishing 3,500 calories, enough to fuel a person through a full day of strenuous activity in extreme cold. It was the original energy bar, a triumph of food preservation and nutritional science. Food storage itself was equally ingenious. Raw hide containers, known as parfleches, were crafted from stiffened rawhide. These beautifully decorated, folded pouches were suspended from the lodge poles, keeping preserved foods safe from rodents and moisture. For longer-term storage of root vegetables and other perishables, underground cache pits were dug. These pits were meticulously lined with bark or grass, and the frozen earth itself acted as a natural freezer, preserving the contents for many months, ensuring a steady supply of vital nutrients through the harshest parts of winter. Every aspect of their existence was a testament to meticulous planning and profound understanding of their environment. The ingenuity extended beyond individual dwellings to the very layout of their camps. When a community established a winter camp, the lodges were meticulously arranged in a large protective circle. Each lodge was oriented with its entrance facing east, away from the prevailing westerly winds, offering an immediate buffer against the most common cold drafts. But this circular formation served a far greater purpose than just individual protection. The collective arrangement created a massive communal windbreak. The outer ring of lodges absorbed the brunt of the icy winds, creating a more sheltered, calmer microclimate within the center of the camp. This strategic layout maximized the collective warmth and comfort for the entire community. Inside each lodge, a family of 8 to 10 people would live through the winter. This density, combined with the small central fire and the extraordinary insulation, maintained a comfortable interior temperature of 60 to 70 degrees Fahrenheit. Consider the stark contrast. A cozy, livable interior, while outside, the world was locked in a brutal -30 degrees. This wasn't merely survival, it was a testament to a harmonious relationship with nature, where every element, Every design choice represented thousands of years of observation, experimentation, and refinement. The life of these ancient architects, their incredible lodges, and their unparalleled survival strategies is far more than a historical footnote. It is a profound demonstration of human ingenuity, adaptability, and a deep scientific understanding of the natural world, cultivated over millennia. Long before our modern world developed thermodynamics or sustainable design, these remarkable people had mastered them. Their dwellings were not just shelters, they were sophisticated, living systems, perfectly tuned to their environment. Every pole, every hide, every seam, every ritual, every piece of clothing, every preserved meal, all were interconnected, forming a holistic system of survival that allowed entire civilizations to not only endure, but to truly thrive in conditions that would challenge even the most well-equipped modern expedition. Their knowledge was earned through generations of observation, trial, and error, forged in the crucible of harsh winters. It is a legacy of resilience, a blueprint for sustainable living, and a powerful reminder that true innovation often comes not from complex technology, but from a profound connection to and understanding of our natural world. We, in our modern world, have much to learn from these ancient masters of the cold, whose wisdom continues to echo through the ages, challenging our perceptions of what is truly primitive and what is truly advanced. Their homes, their lives, their very existence stand as monumental proof that the human spirit, armed with intelligence and respect for nature, can overcome even the most formidable challenges our planet can throw at us.